Hey guys, hey, we're at another stoichiometry practice sheet number 1. This time we're going to be doing problem number 2. So it's mass to mass. So we're not doing too much anything different than we did on the previous problem. We have our 7 different steps that we're going to abide by. So again, the first one is write the skeleton equation. So we're at the skeleton equation. We got to read the question itself, and it says aluminum metal reacts with zinc chloride to produce zinc metal and aluminum chloride. So really we have a single replacement reaction here. And that's our skeleton equation. So let's go ahead and start right out like we normally would. So let's start out with aluminum. There's the symbol for aluminum. We always have to ask ourselves, is aluminum diatomic? Any metal by itself, I should say. We have to ask, is it diatomic? So let's go to the periodic table. We look at it. Aluminum is right here. And again, the diatomic elements make a 7 on the periodic table, starting right here. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine. There's our 7 plus our hydrogen. There are 7 elements. So aluminum is not diatomic. So we're going to go ahead and get rid of that and put that back down. So it's not diatomic, so we can just leave it alone. It's all by itself. And that is going to react with zinc chloride. Now, zinc chloride, if I go ahead and put this in here, we know that zinc is what charge? I believe it's a +2 or a 2+. And then chlorine is going to be a -1. Okay, but let's go ahead and look at the periodic table and see what it is. So let's see about zinc. Zinc is right here. So is it, if there's no Roman numerals, so we know that it's monoatomic. And we know that chlorine's right here, so that is a -1. So let's scroll down to the page 13 that we have our monoatomic ion sheets on. So we'll go down to 13. Oh, we're getting closer there. There we go. One more. And here it is. Well, zinc is a +2, like I said, and chlorine is a -1. So let's go ahead and get rid of that. So we know that they don't cancel each other out. So what do we have to do? We have to crisscross. So we're going to put a 1 right here and a 2 right there. And we can put them in like this if we want to. Okay, so we got them in there. Now it's going to go, so zinc chloride is going to be, our symbol for zinc is going to be Zn. There's only one of them, so we don't put a subscript. Then we're going to put our Cl with a subscript of 2. Now, that is going to equal or yield zinc metal, so we're going to do Zn. And then we ask our question, is it diatomic? Well, it's not one of those 7 or hydrogen. Okay, so we know that it can be just a metal. And the other byproduct is going to be aluminum chloride. So now we have to figure out what is the formula for aluminum chloride. So I'm just going to do it right here. Aluminum, and we know that it's Cl. But aluminum is what charge? Well, I know the column that it's in, so I know that it's a +3. And chlorine is a -1. So they're just going to switch. So this 1 goes down here, so we don't have to put that in there. This 3 goes over here, so we're going to put a subscript 3. So there is our aluminum chloride. So now we have our balanced chemical, there's our unbalanced chemical equation, our skeleton problem. And I'm just going to leave that right there, just to help out maybe. Okay, so let's go ahead and balance it. So how are we going to balance it? We're going to go ahead and put over here, we have aluminum on this side, aluminum, and there's only 1 there. And then we have zinc, Zn, and no subscript right here. There's no subscript, so there's only 1 there. And then we have our chlorine right here. So we're going to go ahead and put our chlorine in. And with our chlorine, though, we have 2. So we have a subscript of 2. Now let's go to the other side. On this side, I have aluminum, okay, which I want to keep them the same. I only have 1. I'll put 1 there. Okay, right here I have our next one is zinc. It says zinc metal. We only have 1 of those. Then our chlorine down here at the bottom, Cl. we have three of those from this right here. So there's 3. So I have 1, 1, and 3. And so I'm 1, 1 good. So the only difference right now is the chlorine. So let's go ahead and look at the chlorine. How do I change chlorine? Well, here's a hint. When we have it even and odd, everything else is balanced, we double everything. So let's go ahead and double everything. Let's say we have 2 aluminums. We're not going to double the chlorine yet, but if I double this right here, or we're not going to do that. Let's do it a different way. Let's just go ahead and see what we have. If I have 3 chlorines right here, and I have 2 on this side, what's the lowest number they have in common? It's going to be 6. So we're going to go ahead and put a 3 right here, which that means we have 3 times 2. Okay, so that's going to make this number over here a 6. Okay, and I'm going to make this number over here, I have to go 2, right? We're going to make that one a 6. So we made each one a 6. So 3 times 2 is 6, 2 times 3 is 6. So I can get rid of this. Now they're the same, but we caused a few other problems. So we're going to go ahead and we're going to strike through those that are not there yet. And again, I did a little bit different. There's lots of other ways. So we're going to chase it. So when I did 3 here, that means I have 3 there. So we're going to go ahead and get rid of that side. Okay, strike through. And on this side, when I did this, that means I had how many aluminum? I have 2 aluminum. Okay, so we're going to get rid of that. So now I can change coefficients. So I have 2 aluminums at this side. How do I get 2 on this side? What coefficient? What times 1 equals 2? So we're going to put a 2 there. Okay, so that means that now our aluminum is correct. And we're going to go ahead to the zinc. I have 3 zinc on this side. I need 3 on this side. I only can change this, so I'm going to put a 3 right there. That means that changes to a 3, and I can get rid of the other one. And now we're balanced. So let's double check. I have 2 aluminum here, 2 aluminum there. I have 3 zinc here. I have 3 zinc here. I have 6 chlorine here. 3 times 2 is 6. And then 2 times 3 is 6. So we're balanced. So there's that. So our molar ratio is 2 to 3 to 3 to 2. And then I always ask yourself, can we reduce that? So no, we can't. So we're done with that. We have our molar ratio. So now that means that we have a balanced chemical equation. So after the balanced chemical equation, we're going to go ahead and start our stoichiometry. So we're going to scroll down here just a little bit. And we're going to start our stoichiometry. So what do we start with? Well, we start with, right here, with the mass in the problem for this one right here. So whatever the problem starts with, that's what we have to start with. So let's look at the mass of 45 grams of aluminum will react with how many grams of zinc chloride. So I'm just going to go, if I have 45 grams of this, and I'm asking for how much of this do I need. So if I have 2 to 3, so there's my ratio. So we're going to go ahead and start right off with the number that's in our question board. That's going to be grams of aluminum times in a line. And again, this is grams. I forgot to put the grams in there. Grams of aluminum. So when we do this, we have to put moles on top, grams on bottom. Why do we put grams on bottom? So we can cancel it out. So I'm just going to do our molar mass here. So 1 mole of aluminum, okay, and we're going to highlight this. Or not highlight that, but underline that. And on the bottom side, we're going to put our grams of aluminum. Now again, how do we get our grams of aluminum? Our grams of aluminum, we have to go to our periodic table. So let's go back to our periodic table and scroll up to the top. Okay, let's see if we can figure out what this is. And let's go all the way back up and scroll down and find aluminum. Here's aluminum right here. So aluminum weighs 27 grams for 1 mole. Okay, remember the atomic weight is that. So we're going to go back to this, and we're going to say that this is 27 grams. Another way that I could have figured out is that I know that in aluminum, so the molar mass equals our aluminum, and I only have one of them, so 1 times 27 equals 27 grams, okay, of aluminum. So there's our molar mass. That's how we show the work for that. Okay, so let's go back to the stoichiometry problem. I have grams of aluminum here and grams of aluminum down there, which means I have one on top, one on bottom. So I can go ahead and get rid of both of those. So we're going to do that. What that tells us now is that now we have it in moles of aluminum. So now I can use my molar ratio to go from one to the next. So we're going to go ahead and put our times in a line. And again, we're going to have moles of aluminum here, so we're going to put moles of aluminum in the bottom. Now, how does that equal out? Let's just, how many moles? Well, it's 2 moles of aluminum, okay, because we have to go back to the balanced chemical equation. So once we go back to the balanced chemical equation, we can see that. So we're going to have 2 moles of aluminum equals how many moles of, what are we looking for? Zinc chloride. So zinc chloride is right here, and so we're going to put that on top. So we're going to put 3 moles of zinc chloride, ZnCl3. And again, we can go ahead and underline this part right there. And now we have that. So now that's good, but we can get rid of something. I can get rid of moles of aluminum here and moles of aluminum there. So we're going to go ahead and cancel those out, get rid of them. Don't forget to cancel these out. So even if you do it on paper and a pencil, you need to remember to strike those through and get rid of them. So now I have moles of zinc chloride. So now I have to convert it from moles to grams, because that's what the questions ask. It says how many grams of zinc chloride. So we're going to put our times in our line. Okay, and now I have moles of zinc chloride, and when we convert from moles to grams, we're using our molar mass. So we're going to put down here, and I have to get rid of this because I always forget to move that over. We're going to have 1 mole of zinc chloride, Zn. Oops. There we go. ZnCl3. That equals the molar mass. So up here we're going to put in grams of ZnCl3. We know that equals. So how many grams is that? Well, we have to figure out the molar mass of zinc chloride. So we're going to go back over here. So we're going to say that we have zinc chloride. So we're going to have zinc. And in that, we look at zinc chloride. There's only 1. So we're going to have 1 times whatever zinc is. So how do we do that? Go back to our periodic table. And we have the zinc right here is 65. So let's go ahead and put that back. So we're going to do 1 times 65 equals 65. Now the other element that's in there is going to be chlorine. Chlorine, how many chlorines do we have? Well, we have 3 chlorines. So in this, oh, it's 2. I made a mistake. That should be 2. This should be 2. Good catch. Okay, so it's going to be 2. So now we know that it's zinc chloride, and we know that we have 2 times, what is the weight of 1 chlorine? Well, we'll go back to our periodic table. 1 chlorine is 35. So we can go back over here and put 35. 35 times 2 equals 70. So the molar mass are those two equal to each other? So 70 plus 65. If it was both 70, it would be 140, but it's not. It's 5 less, so it's 135. Okay, and that's going to be grams of ZnCl2. Okay, so there's that. So we're going to go ahead and put that right here. So we're going to go ahead and put in here 135, And then we'll go ahead and underline all that. We got rid of it. Now if I look at my problem, I can still get rid of something. I have moles of zinc chloride right here, so we're going to get rid of that. And I have moles of zinc chloride down there. Everything's the same, so we can get rid of it. If it wasn't the same, we can't get rid of it, but it is the same, so we can get rid of it. So now when I get to the end, I know that at the end I'm going to have grams of zinc chloride. So I'm going to go ahead and copy this, and I'm just going to paste that right there. So I'm looking for this right here, and we got to remember it's got to be in 3 significant figures. So let's go ahead and do the math. So let's pull up the calculator, and let's see, we have 45 divided by 27. Remember, we multiply by the top, but we don't have to do the 1. Divide by the bottom, the 27. Then we're going to multiply by 3, divide by 2. Okay, that's this. Multiply by 3, divide by 2. We're going to multiply by 135. And hit equals. And so I have 337.5. I'm just going to put that in there. 337.5. And that's what it says that I should have, that I need of this. So if I had 45 grams of aluminum, I would need 337.5 grams of zinc chloride. But I need it in 3 significant figures. So 3 significant figures is right here, we draw a line right here. The 5 says, since I don't have anything after it, I have to use that funny rule that I have that says we look at the previous number. The previous number is odd, so we have to round up to make it even. So we're just going to go ahead and get rid of that and put in the 8. Now, either way, if you just round up with a 5, it would work. But there was no numbers after the 5, so we had to look in and do that rule. So once we get done with that, we go ahead and we highlight that. And there's our answer. But as always, I want to go back and double check and make sure that I did it right. So we're going to do 45 again, do the math again. And we're going to multiply by 1, divide by 27. Multiply by 3, divide by 2. Multiply by 135, divide by 1 equals, and we came up with the same answer. So as long as we came up with the same answer a couple of times, we can go ahead and make sure that that's our final answer. We highlighted it, and there we go. So if I had 45 grams of aluminum, I would need 338 grams of zinc chloride. And we're going to make that look a little bit better right there. So that's our final answer. As always, go Mohawks. Nelson out.